this video I am going to teach you about how exponential growth curves like the one with the virus doesn't just go straight up and continue forever. They actually turn and form almost like a little S. Stay tuned and I'll explain more about it and how you can actually see this inflection point right here well before other people. Normally it's assumed that an exponential growing curve like the virus we have around the world will just continue straight up forever, and that's totally not true, because there is a limit on how many people there are in a given country. For example, in the Philippines, let's say there's 100 million. Common sense tells you you can't go to 150 million because there aren't that many people. The other thing is, as you start getting up to a number of people that have recovered from the infection, the spreading of the disease starts slowing down and it forms sort of an S-curve here. And sometimes it's hard to know when that has started, and in this video we're going to show you how you can actually find this inflection point here very easily with a simple tool. I need to make a small disclaimer that I'm not a medical professional, but I am an engineer and a data scientist, and I am trying to make some sense out of all the confusing information that's floating around there out on the internet, and try to give some prediction and stability to the Filipino people that I love very much, and foreigners that wish to travel to the Philippines and when they're safe to do so. When you look at all the numbers from the countries around the world, you can go to this website, Worldometer, and you get totally confused. You got active cases, closed cases, linear, logarithmic graphs. You could dive into the actual countries. For example, USA, you have a breakdown by state, then you got total cases, you got daily new cases, active cases, you got deaths, total deaths, you got daily new deaths. I mean, it just goes on and on and on. So what should we focus on to actually decide whether we have actually hit the inflection point on the S-curve? It's actually called the logistics curve in mathematics, but we'll call it an S-curve for now so we can keep it simple. And to make matters even worse, the topic of testing for the virus is problematic. Seems like some countries, including the Philippines, are only testing some of the cases that are coming into the hospital for treatment. It seems like some VIP personnel are being tested before regular people, and there was not enough testing kits in the Philippines up through the middle of March. Recently they got some new testing kits by donation from Singapore and China, so things are improving, but still there is not like a random uniform sampling of the population to get an idea of how or what % of the people are actually infected. And you also got false positives from some of the test kits. In fact, some of the test kits from China was claimed to be only 40% accurate, so that's another problem. And all medical tests have a % of false positives, and the Philippines has now currently 11 test kits that they're using. So what are the false positives, the percentages for each of these 11 different test kits? We don't know. On top of that, the hospitals in the Philippines are assuming every patient with a respiratory symptom is the infamous virus. And then you got the regular influenza and respiratory problems that happen every year in every country, including the Philippines. And there's 75,000 people that pass away in the Philippines every year. That's about a little bit more than 6,000 people per month. Now that's going to skew the numbers, especially if the hospital are treating all the respiratory patients as the infamous virus. A new study came out from Los Angeles Medical Center in March of 2020, where they tested 135 flu-like patients that were coming into the center, and they found that only 5.3% of the patients with flu-like symptoms had the infamous virus. Compare that to the Philippines, where they are assuming every patient coming in with flu-like symptoms is carrying the dangerous virus. So that tells you they are overestimating the number of cases by an order of magnitude. In other words, probably around 95% of the patients that come in with flu-like symptoms in the Philippines, unless they're tested, are just ordinary flu. This is going to skew the numbers quite dramatically, incorrectly, and make it look worse than it really is. It's sort of like a fear-mongering gone crazy. And then we got yet another factor of weather, temperature, sunlight, humidity, and how that can affect the virus. In fact, ultraviolet light has long been used for disinfecting entire buses, and utility companies use it for disinfecting water, and humidity probably plays a factor as well. And if you look at the hardest hit areas around the world, they all seem to have a similar temperature zone. It might be almost impossible to try to model the spread of the virus accurately, but what I am suggesting is to ignore all the problems with testing by going straight to the number of people passing away and using that as a measure for how the virus is spreading or retreating. An interesting study was done on guinea pigs and humidity with temperature to see how an influenza virus was spread with various conditions, and they found the higher humidity was preventing the spread of the virus, completely blocked at humidity of 80%, and then at 30 degrees C, which is common temperature in both Thailand and Philippines, no virus transmission was detected. And when you look at the Bangkok with annual temperatures above 29 degrees C, and you compare that to, say, places like Italy or Spain, where there are a lot of people having problems, you realize, yeah, that's a positive factor in favor of lower sickness amongst the people in both Thailand and Philippines and other Southeast Asian countries where the warmer weather is predominant. But don't make the mistake of assuming just because there is a correlation between two variables, for example, a hotter weather pattern and less virus, that there is a causative effect. It could just be that people are going out more in the hotter climate and they're not spending so much time inside in contact with each other, exchanging air. So how do we find out how long the virus scare is going to last in the Philippines, or any other country for that matter? Well, first we need to recognize that the logistics curve, or the SCurve as I call it, is very symmetrical. You can actually see by looking at this graph that the number of people below and above the midline is equal, and also the time from the start of the growth to the midpoint, the inflection point, the turning point, is equal to the time after the turning point to the end of the epidemic. Another point to remember is that all physical processes are a little bit noisy. Even though you may have a mathematical formula for the process, there's still going to be some noise or some randomity in your measurements. For example, the height of men and women are pretty well defined, but when you go to measure the actual height, there will be some variance and noise in the data. And it's the same with plotting these virus curves from around the different regions in the world. They are not going to all fit on an exact smooth curve, and we've known for about a century now that quantum physics is not a smooth process. There is some variability always. That's the nature of our reality, which is due to practical measurement errors as well as the consciousness directly influencing matter. Now, starting with the graph of the virus growth in China, you will find it a little bit difficult to see when the inflection point is started. You will find it much easier if you go to the slope of this growth curve, which is basically the daily increases of cases, and you can pretty much see the peak of the curve there with a little bit of noise from the measurements, and you can estimate how long it will take before the virus epidemic is finished. As we mentioned earlier in this video, due to the lack of testing kits in the Philippines, there are better methods of measuring the spread of this virus, which would be the number of deaths per day. But the problem with that is the number of people passing away is relatively small, so it gets noisy. So we'll revert to measuring the number of cases. In fact, we'll use the number of new cases so we can see the slope of the growth curve for the SCurve, and use that as a proxy or as a relative measure of how things are going. Of course, if suddenly the Philippines gets a large donation of testing kits and they start using that, suddenly we might see a spike in the number of cases. So then that would be a problem. But for now, let's just use the number of new cases to see the slope of the SCurve. So it looks like as of April 3rd, the Philippines still has not reached the turning point or the inflection point on the SCurve. But was it to reach the inflection point tomorrow? It looks like there are about 3 weeks of time for the beginning of the SCurve, and that would mean it will take another 3 weeks for the spread of the virus to basically die out. So that puts the end of the virus spread of the problem around April 25. Now, we don't know how this will play out because the Philippines is a country with 7,000 islands, and 2,000 of them are populated, and with the travel restrictions between islands, it's like the possibility of like a drawn out flattened curve between all the many islands, and the virus spreading will be very drawn out and could last all summer. But hopefully the good weather of the Philippines, the strong sun and the humidity will answer the president's prayer of sparing the Filipino people from a long battle with the virus. I have made a web page with a daily update and smoothing of the government numbers, because some of the numbers are pretty noisy. It's hard to tell what's going on. So you can check in on the website on the link below this video, and you can see the actual smooth curves. And when the day comes when you see the inflection point, you can just count the number of weeks from March 14, when the virus really took off, until the inflection point, and then add the same amount of time from the inflection point forward, and then you will know approximately when the virus will be over.